Well, good afternoon, and hope you're enjoying your fast-paced, short little day. Today's lesson will be kind of a short one. I was going to be talking about continuity on an interval. It's a graph can be continuous on an interval. It means it doesn't have to be continuous the entire way through. So the interval from A to B, if the graph is continuous on all points in that interval. So you can see here we have a piece of a line. Now maybe that thing continues on past that spot and does something else, or continues on past this spot and then jumps. That part doesn't really matter. It's just what's happening on this little piece that we're looking at. And during that distance between left or right, from A to B, that graph happens to be completely continuous. Now, does it have to be continuous at the end points? Well, not really. Excuse me. We could have a picture where, like the red one here on the top left, where we have a colored in circle on the left but not on the right. We would call that graph left continuous. It means on the far left end it's still continuous, and continuous in between the points A and B, but when you get to B it's not continuous anymore. That'd be on the right hand side. And then the notation for that is we use a bracket on the outside of our interval for a colored in dot. The end is part of the answers, and we use the parenthesis when it is not. Now, the second one on the right in green there, that would be the reverse, where the graph is open circle on the left but the closed circle on the right. So it's continuous in between A and B, but it's also still continuous at the end point B. And since that's on the right, we call it right continuous. Well, the other two possibilities down here, we could have one that's continuous on both ends, both colored in circles, like the blue one there. We'd call that left continuous and right continuous. And notice the notation would have a bracket on both ends. Or we could have one that's not continuous at either endpoint. So it has no endpoint continuity, but it's continuous in between A and B in all points, just not at the ends. So again, notice the notation where we have the parentheses. And so let's look at an example. This is what your work will be like today. We're asked to find all intervals in which the function is continuous. So let's start over here on the left-hand side. It looks like on the left, that is going, an arrow on the left over here. I see the arrow, so it's going all the way to negative infinity because it's pointing left. And on the right-hand side, that circle looks like it's at -4, but it's not colored in. So we put the bracket, or the parenthesis. The reason we put the parenthesis with the negative infinity is because you can't actually get to negative infinity. The definition of that means it goes forever. So we don't really know if the end is open or closed because there is no end. So we just use a parenthesis. Now let's look at this next section here in the middle. And that one has closed end on both sides, so I can use brackets on this one. On the left-hand side, this dot right here, it is at -4. And on the right-hand side, that dot there is at 0. Then I have another section over here on the right-hand side. It looks like on the left, that's an open circle, also at 0. And then on the right-hand side, that looks like, it's kind of an arrow, so that means we're going out to infinity. We also use a a parenthesis on that one. I want you to notice that the numbers that are repeated, like the -4 and the 0, one will get the bracket sometimes, and one gets the close, because again, one's got a closed circle, one's got an open circle. So you get a kind of a mixture of those kind of things. But again, for the most part, this is all you're doing today, is just kind of getting used to these smaller intervals of continuity as opposed to an entire line being continuous. All right, the Zoom's still open today. Get me on there if you need any help or want to have any questions. Thanks. Good luck.